Good morning. My name is Martin Blazer. I have the privilege of chairing PACCARB. I'd like to welcome everyone to the 23rd public meeting of PACCARB. Joining me is Dr. Michael Apley, the Vice Chair of PACCARB. And now I'm going to introduce to you Dr. Jumana Musmar, our designated federal officer, who will proceed with the rules of engagement and our participant roll call. Dr. Musmar.
Thank you, Dr. Blazer, and welcome everyone to our 23rd meeting of the Presidential Advisory Council on Combating Antibiotic-Resistant Bacteria. Welcome, welcome. As Dr. Blazer mentioned, I'm Jumana Musmar, the designated federal officer for the Advisory Council, and I'd like to thank all of our presenters, attendees, and stakeholders for joining us today, including those of you who've provided public comment both online to the CARB mailbox and plan on providing it in person later on this afternoon. The Advisory Council was initially established via an executive order in 2014, and then in 2019 we were codified into legislation through the Pandemic and All Hazards Preparedness and Advancing Innovation Act. The goal of this Advisory Council is to give the Secretary of Health and Human Services advice, recommendations to improve the programs and policies related to antibiotic resistance. To accomplish that mission, the PACCARB strives to address the issues related to antibiotic resistance through a One Health approach, which is evident in all of our proceedings and products. Today is the first of our two-day meeting. We will focus today on the environment, climate change, and AMR. We will hear from a variety of subject matter experts as the Council continues to explore the impacts of this evolving issue through a One Health lens. Also, towards the end of the day, our innovation spotlight and public comment periods will commence. Again, thank you for everyone that's provided a written feedback, and if you'd like to provide feedback, please email CARB, C-A-R-B, at HHS.gov. And the copies of those submitted are provided outside at the registration desk. As for tomorrow, you may recall that Secretary Becerra tasked the Council last year with exploring how the United States may leverage national existing pandemic preparedness frameworks to strengthen our defense against antimicrobial resistant pathogens in response to a potential future large-scale disease event. I am delighted to report that the Pandemic Preparedness Working Group has completed their draft, and tomorrow at the Great Hall of the Hubert H. Humphrey Building, the PACCARB will be hearing from the 8 chairs, and we will be deliberating and then voting on the proposed recommendation report that will be transmitted to the Secretary, if approved by majority. We hope that you can all join us tomorrow as well at HHS headquarters at 200 Independence Avenue at the Hubert H. Humphrey Building. But before we start, there are a few things you should know. This meeting is being recorded and is also being streamed live at HHS.gov. And the Advisory Council is governed by the Federal Advisory Committee Act, or FACA. Regarding the conflict of interest rules, all 15 voting members of the Council are considered special government employees, or SGEs, and are subject to conflict of interest laws and regulations. The 12 regular government employee members, or RGEs, representing different agencies and departments on the Council, have also been vetted for any conflicts of interest. Lastly, I would like to thank the amazing PACCARB team for, again, putting together this meeting, along with the previous meetings, Ms. Sarah McClellan, Ms. Haley Krem, Ms. Chloe Loving, Dr. Zaina Francis, Dr. Mark Kazmierczyk, and the Griffin team. And last but not least, Ms. Jennifer Adana, for adapting to the many changes that we've had to incur to hold this meeting together, and we're delighted to have you all here. So thank you, and thank you to the PACCARB team for their efforts to support the working group, this council, and plan for this meeting. I will now go through a roll call for all council members. Please let us know if you're presenting by stating here. For our alternate representative members, please identify yourself and provide the name of the principal you are representing today. We'll start with our voting members and our chair, Dr. Marty Blazer.
Here.
Our vice chair, Dr. Michael Apley.
Here.
Dr. Stephanie Black. Here. Dr. Helen Boucher. Here. Dr. Virginia Fate, are you with us virtually?
Yes, ma'am.
Thank you. Dr. Christine Ginocchio. Here. Dr. Locke Carricker.
Here.
Dr. Elaine Larson.
Here.
Dr. Ramanan Lakshmanarian.
Here.
Mr. Armando Nahum, have you been able to join us? He's absent today. Dr. Payal Patel. Here. Dr. Paul Plummer.
Here.
Dr. Julie Simjak.
Here.
Dr. David White, virtual land.
Here.
Thank you. All right, moving on to our liaison members. On behalf of the American Association of Extension Veterinarians, Dr. Carla Houston. Here. Thank you. On behalf of the American Veterinary Medical Association, Dr. Joni Sheftel.
Here.
Excellent. On behalf of the Biotechnology Innovation Organization, Ms. Emily Wheeler.
Here.
Thank you. On behalf of HICPAC, the Healthcare Infection Control Practices Advisory Committee, Dr. Lisa Maragakis. I think she could be with us today. On behalf of the Minor Crop Farmer Alliance, Dr. James Adaskovich. On behalf of the Pediatric Infectious Diseases Society, Dr. Jason Newland.
Here.
On behalf of the Society of Infectious Disease Pharmacists, Dr. Libby Dodds-Ashley.
Here.
And lastly, on behalf of Wellcome Trust, Dr. Timothy Jenks.
Here.
Thank you. All right, on to our regular government employees. For the USDA, Dr. Jeff Silverstein.
Here.
Thank you. Dr. Sarah Tomlinson.
Dr. Chelsea Shively, here on behalf of Dr. Sarah Tomlinson.
Thank you, Chelsea. And Dr. Kiss Robertson Hale. Thank you. For the Department of Defense, Dr. Paige Waterman.
Here.
Thank you. On to HHS. For the Agency for Research, Healthcare, and Quality, Dr. Melissa Miller.
Here. Can you hear me?
Thank you. For the CDC, Mr. Michael Craig.
Here.
Thank you. For CMS, Dr. Sherry Ling, or anyone else on behalf of CMS with us? All right. For the NIH, Dr. Dennis Dixon.
Here.
Great. For the Office of Global Affairs, Dr. Jose Fernandez. All right. For the Office of the Administration for Strategic Preparedness and Response, Dr. Chris Houchins.
Here.
Thank you. For the FDA, Dr. Bill Flynn.
Here.
Excellent. And for the EPA, Dr. Jay Garland.
Here.
All right. Again, thank you all for attending this important meeting. Just a few more housekeeping items to remember. I ask that council members who wish to ask a question or have a comment to use their name card by popping it up vertically or raise your hand. We'll take note. The moderator for each session will then call on you. Once you've been called on, please remember to unmute the microphone at your seat before speaking, and then mute yourself following your comment or question. For people in virtual land, please feel free to use the raise hand feature that is on the Zoom, and I can see you, and we will call on you. All right, I will now pass it on to our chair, Dr. Blazer, to introduce today's patient story.
Thank you very much, Dr. Musmar. It's my pleasure now to introduce Mr. Bradley Burnham. Mr. Burnham is the founder and CEO of Turn Therapeutics. He'll be speaking to us today not only as a CEO, but also as a patient who has had an AMR infection. Mr. Burnham, thank you so much for sharing your story with us today.
Thank you, sir, for the invitation. Good morning, everyone, both in person and virtually. I'd like to first thank the council for the opportunity to share my story and thoughts, both as a patient and founder working in AMR. Special thanks to Dr. Kent Kester, a charter member of PACCARB, for the introduction.
Can you just move the microphone closer?
Oh,
so
I'm
that
sorry.
we can
I
hear
have
you
trouble
better?
with microphones. Can you hear me okay now?
Better.
All right. Thumbs up. Special thanks to Dr. Kent Kester, charter member of PACCARB, for the introduction to the council. This is obviously a very personal topic to me, and it's become my life's work. So the honor is very much mine to be here. So thank you. I'm going to begin today by borrowing some words from Alexander Fleming himself. Allow me to sound a note of warning. AMR is not a looming threat on the horizon. It's here. Its soldiers are in this room, our homes, our schools, our workplaces. We can't see them, but they're here, and it's not a fair fight, as we all know. There are millions of microbes in every cubic foot of air. They outnumber all humans on Earth combined by 10 to the 22nd. They outweigh us by 10 to the 8th. They get better and stronger generations of soldiers every 20 minutes, born trained against whatever the local threat may be, and us. We're at a standstill over how to mount a counteroffensive. As a former patient and citizen, I'm frankly ashamed, given the number of less urgent initiatives this nation funds to protect its citizens. Choosing to incentivize AMR developers or fund AMR research may be expensive. It may even be partisan, but the cost of stagnation is not red or blue. Extinction affects everyone equally. We are here because we have to start making choices. Ignoring AMR is no longer an option. Mother Nature will win. She always does. My life has been consumed by choices since the day I began battling a recurrent and resistant infection. Some have been personal, some have been professional, some have even been quite painful. None of them have had straightforward answers. But choosing an action was never an option. An example is the first choice I had to make the day I learned that I needed emergency surgery to slow the spread of my infection. It seemed like a benign choice at the time. Boy, was I wrong, by the way. I had two options that day: get admitted to the hospital I was standing in, or go to the private surgery center of a family friend who offered to open his doors and scrub the case himself on a Saturday. I chose the comfort of a friend. And while I'll never regret that, that choice came with consequences. The surgery center did not have an anesthesiologist that day. Little did I know that infections like the one I had, one that had rendered my entire ear and side of face purple and cellulitic, they eat local anesthetics, rendering them completely useless. So I stomached ongoing, repetitive, fully circumferential nerve blocks to the entire side of my head, over and over and over. I lied there for 4 hours, losing pieces of my face, my earlobe, listening to the electrocautery millimeters from my eardrum burning away infected tissue, filling the room with smoke, scalpels scraping away branches of infected cysts that would plague me for years with recurrence. I had to choose again and again: please inject me with dozens more shots of lidocaine anywhere a nerve impulse might exit, or just deal with the pain. Talk about a no-win. I remember going back and forth a lot. That burn isn't as bad as the last one. That scrape hurts too much. After hours of cutting and 4 layers of 50 stitches, I was educated. Grateful, granted, but quite educated. And on the subject of choices, let me tell you about some choices I've had to make as a CEO working in AMR. Having been on the sharp end of a scalpel nearly 20 times and in a boardroom fighting this global pandemic, I can only think of one way to describe the current state of this space. It's rudderless. The top does not see the upside. The bottom can't get the funding to start. It seems to have zero direction. Let me illustrate what I mean by that with yet another personal story. I've spent the last several years advancing the candidate I created to stop my recurring infection. That's part of my story. I invented my own cure by building a lab in a garage with secondhand machinery and imported chemicals. And in 2016, I completed my first FDA clearance entirely on my own, with nothing more than a credit line on the FDA help desk. The product hit the market shortly thereafter, albeit with limited indications. Now, having the product in circulation was very educational. I followed the use patterns closely, and I learned 2 things early that it was exceptionally good at: closing stubborn, stalled, critically colonized wounds, as I intended it to do, and clearing up toenail fungus. It actually became an off-label phenomenon of sorts for toenail fungus, but because I could confirm with real-world human evidence that it was good at something, I was granted the opportunity to sit down with a well-known investment banker to get some early advice on the pathway forward, which would include, of course, raising capital for clinical development. I'm going to skip to the punchline of that meeting. There is no investment capital for infectious diseases like the one I suffered through, but discolored toenail fungus is a gold mine. I'm going to let everybody sit with that one for a moment. Toenail fungus should not be more valuable than limb salvation, but it is. And the why is as obvious as it is infuriating. Money. It's always money. Antimicrobial development still can't produce a worthwhile return for investors or big pharma, and as a result, we have the driest pipeline in history amidst an ever-worsening resistance crisis. But we've heard this story before and seen solutions in other areas, such as rare diseases. We needed federal assistance for treatments to be profitable then too. To spur innovation, the Orphan Drug Act was passed in 1983. It dictated that if an organization studied a qualifying rare disease in the United States, it would be eligible for tax breaks on clinical trials, free NDA review fees, extended exclusivity periods, and huge reimbursement multiples, and it worked. Those incentives fundamentally reshaped investment patterns in pharma. Small population diseases became preferred targets for venture capitalists, but we have nothing like this for antibiotics or antimicrobials. Now, the question is why? Why is there a huge economic advantage for a company like mine to study a rare disease that has yet to affect a single person in the United States, rather than an infection like the one that I had? Rudderless, like I said. Subscription models like the Pasteur Act are an incredibly encouraging start. But we will not end the standoff until we create incentives that approach the problem from all angles, top down and bottom up. We're living in a dream world to think otherwise. We already know what a world without antibiotics looked like. Less than 100 years ago, skin, knees, and battlefield injuries were amputation risks. And it's sad that I had to learn from trauma, but the public doesn't know the consequences of severe bacterial infections. So how do we cause change? How do we drive a movement before more people like me suffer an avoidable fate? Economics are part of too many conversations around AMR. Antibiotics may not be the kind of value-driving assets that CAR-T or neural implants have become, but how valuable will those cutting-edge treatments be if their use is lost or compromised entirely due to AMR? I find myself marveling that we let this happen in the first place. It's not like we weren't warned. Fleming told us in 1945 that he was already seeing resistance in laboratories and that misuse could cost us the benefits of his discovery, and we ignored him. Someday soon, I desperately hope we cure cancer. And I hope, like Fleming, the lead for that technology also receives the Nobel Prize. If that person stands on stage or in a group like this and warns us that we could lose the cure for cancer by misusing it, I ask, will we listen? How do we let this happen? The easy answer is, of course, to blame physicians for overuse, but studies have shown that they're pressured by patients to give everyone with a runny nose a Z-Pak, or else they risk negative reviews online. Plus, they do not have a steady supply of new antibiotics to pull from. And when that rare new one does finally come along, what do? They lock it in a safe like a fire extinguisher as a last resort. It's a moral obligation. Why? Because the second you use an antibiotic, microbes start learning, mutating, replicating, eating away at the efficacy these new tools may have. There are 500 microbial generations in every human generation. We can't match their speed without a coordinated effort and federal assistance. So while we're debating, politicizing, discussing, they're winning. Until we drive innovation and create a consistent stream of new antibiotics, the safe will be locked and medical innovation as a whole will be at risk. We need to put down our differences. We need to recognize that this is not a time for politics. Pass the PASTEUR Act, fund the pull-through incentives, but don't stop there. Please throw the book at it. Incentivize startups, laboratories, every wild-eyed kid with a chemistry set and a dream to treat infections. Use the tools we already have for rare and neglected diseases to offset early development risk. Just hit copy-paste on the programs we already have. What's rarer or more neglected nowadays than a new antibiotic anyway? Try new tools, even if they may not be obvious or high science enough at first blush. I found the chemical at the center of my invention in a 2010 UK Wound Society consensus document. It's a non-cytotoxic broad-spectrum antimicrobial that has been used as a standard of care for infection control in Europe for literally decades. It's never even been a drug in the United States. Even more troubling, throughout my development process of a better delivery system for this chemical, I learned how few in the infectious disease community here had even heard of it. AMR is a global problem, as we all know. We can't expect every patient like me to desperately hunt down obscure publications from international wound societies looking for ways to self-treat. Government and industry need to join the hunt. Initiatives like One Health are important because they encourage interpersonal collaboration and teach us to value the contributions of each willing participant in the battle. For all we know, the answer to AMR could be right under our noses, growing on another piece of bread somewhere on a dirty workstation. It was Hippocrates who said, as to diseases, make a habit of two things, to help or at least to do no harm. I can personally attest to the harm our inaction is having. I'll just say it like it is. We have enough wrinkle busters, we have enough eye fillers. It is time now, desperately more than ever, that we return to incentivizing development that really matters. Thank you for your time.
Thank you very much, Mr. Burnham. We appreciate your coming here and sharing your remarks with us, both about your experience and about your vision. I think we're going to move on. But by the way, I think you mentioned, if I heard you correctly, you said that there were 500 bacterial generations for human generation. It's actually 500,000.
Oh, wow. I will edit that in my future ones.
Thank you. Okay, so now Thank you so much again. I'd like to excuse you, Mr. Burnham, and introduce our panel and ask our panelists to come up to the table. Our first panel today is entitled Emerging Issues in AMR, a Global Perspective. And we'll be hearing from multiple experts today about the current landscape of AMR efforts from an international perspective. Our first speakers are Dr. Amy Pruden, the W. Thomas Rice Professor and University Distinguished Professor at Virginia Tech University, and Mrs. Fatou Ndoye, I hope I said that correctly, the Acting Regional Director of the United Nations Environmental Program's North America Office. Then we will also hear from Dr. Keiji Fukuda, who is retired from CDC and WHO, and as Director of the School of Public Health of the University of Hong Kong. We will hear from Dr. Robert Skov, the Scientific Director of the International Center for Antimicrobial Resistance Solutions. And we will close out this panel with a presentation from Drs. Joel Denis and Donald Shepard, who are representing the AMR Advisory Group of the Public Health Agency of Canada. Thank you all for joining us. And Dr. Pruden, please go ahead, and welcome back to PACCARB.
Thank you. I appreciate being here. Next slide, please. So I'm Amy Pruden. I'm a professor at Virginia Tech and a co-speaker here.
I'm Fatou Ndoye, and I'm the Acting Regional Director of the UNEP North America Office, in charge of liaison with the US and Canada.
Can I just ask the speakers to move the microphones closer to you? Because if we can't hear you, it doesn't matter what you say. Okay.
Can you hear me okay now? Great. So we are here to talk about the Bracing for Superbugs report that came out from UNEP last month. And I am one of the primary authors, along with Teresa Coque from Spain, David Graham from the UK, Anthony So, who's a professor at Johns Hopkins, and Ed Top from Canada. And I want to highlight that this report was actually developed with the consultation of over 50 global experts, and that the purpose here was basically to provide a state of the science of environmental dimensions of AMR, and also to frame that within context of what we can do to support One Health action against its spread. Next slide. So I don't think I'm out of turn here in pointing out that the environmental aspect of One Health, people, animals, environment, the environment aspect has not received the attention that's needed in order to fully address the AMR issue. And so there are many environmental dimensions of One Health, and we can see some of them here at the molecular scale. We know that antibiotics and antimicrobials, they impose selection pressure, and that allows resistant organisms to survive better in the environment. And we also have movement of antimicrobial resistance genes on mobile genetic elements, and that can create new species of resistant pathogens. And this is all happening in various incubators, so within human, animal, and we also emphasize plant microbiomes, and that we have movement of water, soil, air, and wildlife disseminating these resistant organisms and genetic material across this landscape. Next slide. When we think about antimicrobial resistance as an environmental contaminant, it's a little bit different than when we think of a typical pollutant, in that antimicrobial resistance can be transferred and shared among microorganisms due to horizontal gene transfer, and also that these organisms can be amplified. And so a critical point is that the environment plays a key role in the development, transmission, and the spread of AMR. And so there's three main aspects to this. So the first is that the environment itself, especially, for example, soil, right? We have vast microbial diversity. And so these resistance genes can then be disseminated and acquired by pathogens. The second is that we put out biological and chemical pollutants into the environment, and that these impose selective pressure so that the resistant organisms are the ones that survive. And then the third is simply the environmental dispersal, right? We've seen with the pandemic how fast microbes can move, and in the environment we have water, air, soil, and wildlife contributing to this dissemination. Next slide. If we're thinking of addressing AMR from an environmental perspective, we simply can't ignore the triple planetary crisis. So we've got climate change, loss of biodiversity, and pollution and waste. And antimicrobial resistance touches on all of these. But that also means that there are co-benefits in which we can address these crises and the crisis of antimicrobial resistance. So a few examples. With climate change, we know that many pathogens prefer warmer temperatures that will come with climate change. We also know that with increased frequency of storms, you're going to have increased movement of water and soil and air disseminating resistant organisms. Of course, pollution and waste themselves, that's kind of our focus here, that these are inputs of resistant organisms and the chemicals that select for them. And with loss of biodiversity, we know that antimicrobials are intended to kill off broad swaths of microbes, and so it stands to reason that there will be an effect here as well. Next slide. Within the environmental dimensions, water is deserving of special attention. Of course, water is essential for life, but it can become contaminated by many sources. And we're especially concerned with human and animal fecal material, which will contain resistant organisms and often the antimicrobials that are commingled there. And within the water environment, there is movement between and across environments, so it can be a disseminator of resistance. And this is where we see synergy with water sanitation and hygiene efforts, also known as WASH. So these efforts will not only promote public health, and especially there's focus on these efforts in low and middle income countries. So this will reduce the need for antibiotics, but also help reduce the spread of antimicrobial resistance. But of course, in addition to water, we also, as I mentioned, we have wildlife, airborne and soil-borne dissemination. Next slide. So in developing the report, it was clear that a systems approach was paramount and that this cannot be addressed from one single sector. And so we identified three fundamental value chains within which we can focus on dimensions that contribute to the development and spread of resistance in the environment. So these are pharmaceuticals and other chemical manufacturing, and we look broadly, not just antibiotics, but antimicrobials, pesticides, fungicides. We also have agriculture and food production and healthcare systems. And something really fundamental to recognize here across all these value chains is that prevention is key. That once these AMR-associated pollutants are released to the environment, we have a much more difficult and costly challenge to deal with. Next slide. So the pharmaceutical and chemical manufacturing chains, some options to consider One is in the production of these chemicals, really integrating a life cycle approach to prevent pollution in the first place. Now, when there are wastes that must be treated, it's important to treat them in a fashion that's not going to exacerbate antimicrobial resistance. So, for example, in pharmaceutical production, you're going to have waste streams that can be very high in mixtures of potent pharmaceutically active ingredients. And so those wastes must be managed accordingly. Now, if we talk about waste treatment, then we also need to think about discharge limits. What's the goal? You know, zero isn't necessarily feasible or desirable, but what are these targets? Also within the pharmaceutical and chemical value chains, transparency has been an issue. So we need to promote the sharing of production and use data across these value chains. And then verification, so monitoring potentially impacted environments. Next slide. For agricultural and food value chains, here I would want to point out that this was a broad umbrella. So this also includes aquaculture and plant production, including ornamentals. And similarly, we see that any efforts that can be made to promote animal and plant health in the first place is going to have a co-benefit of also reducing the need for antimicrobial use. Now, when they are used, it's a challenge because it becomes a non-point source pollution, and that is more challenging to address. Now, manure, so this could be human and animal fecal-derived fertilizers. Kind of a double-edged sword here because they are more sustainable than chemical fertilizers, but appropriate treatments and controls are needed. So you can think about treatment from the farm to slaughterhouse continuum, and really thinking about ways that we can contain the antimicrobials resistant organisms and their genetic material. Next slide. And especially within food production environments, we need to pay attention because there's potential for human exposure. And so we thought about in particular, you know, what are the critical control points that can lead to contamination of plant and meat and aquaculture products with resistant organisms, antimicrobials, and genetic material. And then knowing those critical control points, we can then focus our mitigative efforts. Next slide. Healthcare value chains are obviously fundamental as well, and all of the efforts towards prudent use of antibiotics and stewardship as well as hygiene, these help limit the need for antimicrobials and limit the spread of resistant bacteria, so there are co-benefits there. But what about the hospital sewage? That is something that does need more attention. We know that hospital sewage is highly enriched in mixtures of antimicrobials and resistant pathogens, so we need to think about some specialized treatment there. Also, proper disposal of unused medicines. That's also an issue. Next slide. One other thing I meant to mention on the previous slide is the procurement of antimicrobials, right? So where do we get them from? Are we getting them from pharmaceutical manufacturers that engage in best practices? Now here, what the point is that the research is developing. The environment is big and complex, so we'll continue to be learning. Some of the areas where research is needed is coordinated surveillance. And this will be much more impactful if it is coordinated and we have agreed upon targets and measures. And we see some movement in that area and expanding NARMS to consider environmental monitoring as well. And on the international stage, the Quadripartite has assembled a technical expert group to look at how surveillance can be coordinated on a global scale. And we need to think about, what do we target, right? There are many resistant organisms, many pathogens, many resistance genes. And so we can think of different culture, qPCR, and even genomic targets. But we need to think about ways that these targets can be accessible, especially to low and middle income countries. And there is a revolution in genomic science, and this is likely to provide important new insights. Risk science is another area of research need. So traditionally, we have this framework of microbial risk assessment of pathogen exposure. We know dose responses, right? But antimicrobial resistance can break that mold, because we need to also think about the risk of antimicrobial resistance evolving and spreading, especially to new pathogens. And risk assessment can help us focus our efforts where they're likely to be most fruitful, and also can help us to get at this issue of what are our target discharge limits. Next slide. And finally, I'd like to close my part by making it clear that the evidence is there to act now. We urgently need to bring in a robust environmental perspective to our One Health effort to combat the spread of antimicrobial resistance. And we need this at a local, national, regional, and global scale. AMR does not respect borders. And everything that I touched on today is relevant across these scales. So with that, I'm happy to hand things over to Fatu.
Thank you, Amy. Next slide, please. Thank you, Amy, and thank you to the Presidential Advisory Council for the invitation today. I'm here representing the United Nations Environment Programme, and for those of you who do not know UNEP, it is the leading environmental voice in the UN system. UNEP supports member countries in addressing the root causes of the triple planetary crisis of climate change, nature and biodiversity loss, and pollution and waste. So on this slide, you will see highlighted 7 program areas through which UNEP delivers its mission and provide the science and the guidance to develop the regulatory and policy frameworks needed by countries to transform their economies. Just to say that AMR was highlighted in our most recent medium-term strategy at the request of our member countries, and it is featured under our work on chemical and pollution. Next slide, please. So while the environmental consideration in the AMR remain understudied, the actions required are clear, and the report highlights a series of priority actions at the global level. The first one is to improve the existing environmental governance structures, planning, and regulatory frameworks. And I must say that at the global level, the environmental dimension of AMR is being strengthened thanks to the Global Leaders Group on Antimicrobial Resistance convened by Prime Minister Motley of Barbados. There's a tremendous impetus there to really lift the agenda and build momentum around it. And it's really time to look at global coordination. What can we do together to address these challenges? The development of AMR National Action Plan is also another priority. And the hope is to see the environmental considerations into AMR national action plans, as well as the integration of AMR itself into other sectoral national plans, such as those on food safety and security, chemical pollution management, nature and biodiversity loss, etc. The second priority area, as highlighted earlier by Amy, is prevention at the global level. And the report invites countries to identify and target pollutants that contribute to AMR development, transmission and spread, and set up policies and legislation to minimize the release of pollutants in the environment. And the report notes that strategies to prevent and respond to pandemics also yield benefits to addressing AMR. The third priority action is on improving reporting, surveillance, and monitoring. And here, the report recommends developing integrating surveillance approaches and promoting transparency in data collection. And lastly, the report calls for prioritizing financing, innovation, and capacity development to support environmental action. And the report makes the business case for public and private collaboration for sustainable funding and investment in reducing environmental risks to AMR. Next slide, please. Now, as you may know, to respond to the challenges posed by AMR globally, the United Nations created a strategic framework for collaboration on antimicrobial resistance through a One Health approach across several of its organizations: the Food and Agriculture Organization, the World Health Organization, the World Organization for Animal Health, and UNEP. The framework sets out joint work streams, such as supporting the Global Leaders Group, creating a multi-stakeholder partnership platform, setting up integrated system for surveillance, and working through the AMR multi-trust fund partnership to support countries. So I really invite the Council to think about how can this country, how can the US support this global effort as well. Next slide, please. Next slide, please. And I would like to conclude these few remarks by underlying really how AMR has the potential to undermine the achievement of several of the SDGs. I would say on this slide, you will see that 13 out of the 17 SDGs may be completely derailed. And limiting the emergence and spread of resistant pathogens is critical to preserving the world's ability to treat diseases in humans, animals, and plants, reduce food safety and security risks, protect the environment, and maintain progress towards the SDGs. I thank you for your attention.
Thank you, Drs. Pruden and Ndoye. We will have the questions after all the speakers in the panel. Next, we will hear from Dr. Keiji Fukuda about policy considerations. Thank you.
Good morning, everyone. I first want to start out by thanking Dr. Blazer and Dr. Musmar for the invitation to talk with PACCARB this morning. I have a pretty short presentation, and I'm going to go over some of the things that I consider to be relevant policy considerations related to the environment and AMR, but want to give you a little bit of background about my perspective, which has evolved over time as I've gained experience. I first ran into AMR when I was training for clinical medicine, and at that time saw it as an issue of how do we get the right antibiotics for the right patient, given different disease processes, and resistance was often a problem. When I went to CDC, I saw AMR as another one of the many public health issues which the country was facing, but was not directly involved. But then when I went to WHO, AMR became one of my responsibilities And at WHO, I began to look at AMR as a question of how do we take an issue and position it to get the requisite political and I think bureaucratic attention needed to deal with a priority. And then after I left WHO, I went to Hong Kong to the School of Public Health. But there was one of the advisors to the Hong Kong government on AMR, and again began to see more closely what are the local challenges at a local community level in dealing with an issue like AMR. And all of this has gone into inform my sort of perspectives that I have today. Next slide. So if we look at this as in a kind of global context where we are now, I think that it's pretty clear that our attention to antimicrobial resistance really began as a kind of scientific and then eventually medical phenomenon. And the response to that kind of issue was, as you might expect, a fair amount of significant research done, the concern of of professional societies like infectious disease societies, development of a variety of tools such as guidelines on antibiotic selection and so on, the development of clinical surveillance in hospitals, and then a great deal of advocacy really at the professional and civil society level. But in going to WHO, one of the important meetings for me one day was a visit by a delegation from Sweden who said, we as a country are highly concerned about AMR, and we don't believe that WHO or the rest of the world is doing enough about it. And in considering that point, I thought it was true. And this was really a discussion that was then held with a number of other individuals. And so consequent, and what it also dovetailed was with some other discussions with FAO and OIE about how WHO and the three organizations needed to coordinate and work better on issues of mutual concern. And so this is really following the emergence of bird flu and all of the issues that were dealt with related to that outbreak. And this has now evolved to include UNEP, which has been a major addition to this so-called tripartite to become the quadripartite. So as part of the discussion about the need for us to move AMR to a different level of attention, the decision was made to develop an AMR global action plan. And the importance of that plan was to be inclusive to as many parties as possible. And so across agriculture, across veterinary medicine, across human medicine, and so on. And it was that process which really did a lot to bring together a lot of the key players. But this was still in the professional world. And so what was needed was really to engage the diplomatic world. And the eventual goal was to get this issue to be discussed at the United Nations, which took place in 2016 at the high-level meeting. But subsequent to that meeting, to the 2016 high-level meeting, a number of other actions then began to occur. And so with the development of the Global Action Plan, subsequently were a large number of national action plans, which are in various states of implementation, of support voiced by industry and so on. But also as part of this process were the adoption of a number of what I consider key concepts. One of them was an emphasis on a One Health approach, recognizing this was way beyond the health sector. The decision to focus on antibiotics as opposed to all antimicrobial agents, which was also critical in sort of making the issue somewhat easier to understand. Next slide. And so in a lot of ways, this push has really been successful. So for example, in 2024, there will be the next high-level meeting at the United Nations, again, to revisit AMR as an issue. There have been a large number of other initiatives which have been undertaken by various organizations around the world. But it's very clear if you actually look at the rates of AMR and the trends in terms of antibiotic use and so on, that significant more work is needed. And so when I look at those things which are needed, I think probably the single most important one for me anyways is the institutionalization of AMR as a priority really at the community and local level. We have to build upon the global discussions which have taken place, but I think it's at local government levels and the various agencies that the issue of AMR still has yet to be internalized and really adopted as a working priority. And I think that this is critical. We already have a number of existing plans and policies, but you need that internalization to actually implement them and have people push on them. In addition to that, I think that it's clear that we live in a very complicated environment now. There are a lot of priorities, and for them to stand on their own is going to be very difficult. And one of the challenges for AMR is how is it going to be positioned strategically with other global initiatives and other global agendas in order to be able to accomplish the goals needed for AMR. So for example, will it become part of the climate agenda or the triple threat agenda? Will it become part of the pandemic preparedness agenda? I think these are some of the critical positioning and policy issues that have yet to be worked through. We will come to the environment a little bit later, but I believe that as Dr. Pruden has said, it is the part of the AMR agenda which has received the least amount of attention and really needs to get more. There, of course, is the whole area, the need for developing a sustainable long-term ecosystem for the production of antibiotics and alternative therapies, but that's another stream that I won't touch upon today. And then finally, I want to bring up the idea of what I consider indirect public support. I think people in communities do not know what to do with the issue of AMR because what they don't understand is what actions do they take to contribute. So for example, people understand that if they want to help with pollution, they may do recycling. Or if they want to help with climate change, they may use fossil fuels less. It becomes a very concrete issue. And we have yet to do this with AMR at the community level. Next slide, please. Also, I want to point out that there are a lot of outstanding scientific issues which have yet to be worked out more clearly, but I see two of them as being of foundational importance for policy. And one of them is that I think that we still have to make it clear how do we attribute AMR in terms of the various sectors. We have the health sector, which we know drives a lot of AMR. We have the agriculture veterinary sector, which drives part of it. But the same issue and the same question has to be posed for the environment. And this is really a critical issue in terms of resource allocation. You want to have a sense of proportionality, and this is one of the outstanding issues. The second one is that it is very clear in this complex issue that the various sectors interact and overlap in a variety of ways. And we know, for example, again, from Dr. Pruden's talk, that we have a number of issues such as resistant microorganisms, antibiotic resistant genes, mechanisms such as horizontal transfer of these genes between microorganisms and sometimes to pathogens. But can we make those pathways more clear? And the reason for this is that we simply don't understand right now what are the most effective strategies and what are the most effective most cost-effective strategies in going forward in looking at the very complex relationships. Next slide. So in focusing on environmental AMR, again, for policymakers, probably two main questions. One, is there a real concern? And I'll come back to this in a moment. But the second question I want to point out is, what is an adoptable perspective for countries? And the reason why I put this down is that for me, one of the important lessons was in attending a dinner among ambassadors that were trying to educate each other on AMR. and get a sense of where the various countries stood, a small country asked a question of me, and the representative said, "We are a small country. If you are saying that AMR is so important, what do you suggest that we take off of our plate?" She said, "We can only handle a certain number of issues. We only have the resources for handling a certain number of issues. And so what is the credible argument that I should take back to my government?" And in working with various governments, what is the credible argument is an issue which has often come up. And in fact, can this be an issue which can be worked out practically? And so I think that whatever we do in terms of policies, that issue of practicality and credibility is very important. Next slide. So is there a real concern? Yes, and I won't go into the details, but I think that, again, Dr. Pruden has covered many of the various concerns. But to summarize, we know that the environment is an incubator that way predates the antibiotic era. We know that antibiotics themselves are a very strong selective pressure, and we know very clearly that the environment is being increasingly heavily contaminated, both from diffuse sources or non-point sources as well as point sources, and that the point sources themselves often form these hotspots where we see the mixture of antibiotics, various microorganisms, including pathogens, ARGs, or antimicrobial resistant genes. And in that mixture, we see the potential for new forms of resistance to come out. And then finally, as has been pointed out, among the other issues facing the planet right now are issues such as the so-called triple planetary threat. And in those kinds of threats, these are very closely linked to antimicrobial resistance. And so while we think about those other issues and AMR, it's very clear that we somehow need to grapple with both of them simultaneously. Next slide. So just another couple of policy-related considerations which I want to point out. It's again very clear that AMR is a global phenomenon. No matter where you look, you find it, and you find high patterns of resistance. But the patterns themselves are local. And perhaps even more importantly, what you find is that even when you have global problems, the solutions are really local. They cannot be handled the same in all locations because the issues and the resources are not the same. And so this really points out the fact that we have a situation where there's variable willingness and capacity of different national and subnational entities to act. And there are the usual reasons. There are competing priorities. There are always resource limitations. There may be champions, or there may be a lack of champions in any location. And often there is an unsupportive institutional culture. So what you see on paper is not really what is carried around in the minds of the people working there. And so again, the third point that I want to raise is that I am always very concerned about whether things can be done practically and whether we can do them for the long term. And I believe that for AMR, similar to many other issues that we're grappling with, it is going to be absolutely essential to join AMR up with these other global agendas. Otherwise, we are not going to be able to sustain the support needed to grapple with them. Next slide. So this is my last slide, but in essence, I see the policy options at this time for environmental AMR as relatively straightforward. It is possible, on the one hand, simply to argue that we need more research. This is an argument which goes over well when you're not sure what you want to do, and it's always true. We always do need more research, and so you could make that argument and simply hold at that point. But that's not going to help us very much. And so it is also possible on the further end to come up with all kinds of policies which really go beyond some of the practical realities of the time that we live in. And I think it's also not helpful to come up with policies which cannot realistically be entertained or implemented. And so this really leaves us with what I see as the neighborhood for realistic policy issues, which is that in parallel, we need to be continuing with research. There clearly are fundamental issues which we have to understand better. But we also simultaneously do need to push upon policies and actions, and really, I think, focusing right now on reducing contamination of the environment by antibiotics. There are opportunities provided by other agendas. I think, for example, the growing concern about chemicals in the environment, such as phthalates, the increasing attention on how climate change is linked to pollution, to land use. These are all examples of other agendas which really would help us to achieve many of the things which we need for AMR. I think the WASH agenda was again pointed out by Dr. Pruden. And I think that looking at where we can practically align policies for AMR and really to use them more broadly to achieve multiple ends is where we probably need to push on right now. Now, a number of these options have been pointed out in the UNEP report. Other organizations have also pointed out that there are a variety of options for how we may reduce contamination, but I think the point now is that we should pick on some of these and really emphasize them in terms of policy. So, Mr. Chairman, let me stop there. Thank you.
Thank you very much, Dr. Fukuda. I'd now like to turn to Dr. Robert Skov. Thank you.
Thank you very much. And first of all, I would like to thank for the invitation from Dr. Blazer and Dr. Musmar and the whole PACCARB team to come here and present what we are doing at the International Center for Antimicrobial Resistance Solutions, also called ICARS. Can I have the next slide, please? This slide here is showing some of the results from the very recent GRAM data. Is no surprise to anyone in this room. But outside this room, the majority of people do not understand the major threat that AMR poses and the way in which AMR is intersecting with all the other global crises that we are facing at the moment, including climate change. If you can take the next one. And even though that there has been very many AMR interventions developed over time, only a fraction of those that were successful has actually been pursued after the projects have ended, and even fewer see widespread implementation. There's a number of reasons for this, some of which are mentioned on this slides here, which include insufficient political or policy commitment, lack of local ownership, engagement, or behavioral change, and not the least, limited human infrastructural and operational resources. And it's very important to really realize that scalable, successful interventions are based on research that both have an intervention as well as an implementation component. Next slide, please. So I think what we hear today is that sustainability is a really great challenge, particularly in low and middle income countries where there are very many competing agendas. We will all need solutions that are bolstered with political will and commitment that supports the transfer of evidence into policy and action. We will need solutions that are owned throughout the whole chain with buy-in from all stakeholders, from government to practitioners, and all the way into the community. They have to be guided by problems that the countries themselves has prioritized, rather than adopting a one-size-fits-all approach, and therefore needs to be context-specific, tailored to response to local needs and challenges. Based on evidence in order to obtain credibility and acceptance, build on country capacity to support the successful implementations of the solutions, and the solutions need to pay close attention to the enablers for behavioral change in a given context, because only with actual behavioral change, solutions can be true and long-lasting impact. Finally, they obviously needs to be cost-effective, especially in low and middle-income country settings where resources are scarce, and they have to span the One Health spectrum and support cross-sectoral stakeholder engagement. Next slide, please. So ICARS was founded in order to approach these things here and really to get actions on the ground and not leaving them in national action plans. ICARS was created by Denmark in 2018 and is now an independent self-governed organization. We are working in a partnership with governments in low and middle income countries to develop context-specific solutions for AMR, and ICARS is providing both funding and expertise across the One Health spectrum. Next slide, please. In this slide here, you see some central numbers of ICARS. In 2022, we received approximately $8.8 million as direct funding and further $1.9 million as in-kind contribution. The main donor is Denmark, but we have been able to attract earmarked funding from the UK Department of Health, Wellcome Trust, as well as have worked together with the IDRC of Canada and co-fund a project on gender and AMR. The next slide, please. ICARS strategy is organized across 5 interconnected pillars. But pillar 1 is testing solutions done in partnerships with low and middle income countries, which is the main focus of our work. Within pillar 2, we look into existing evidence that has already been generated and identify how we can best translate that into contextually sensitive policies, programs, and practices. For pillar 3, we cover the advocacy and communication efforts, especially with regards to the need for context-specific, cost-effective interventions in low and middle-income countries using implementation and intervention research. Nothing will help if we are not able to see sustained capacity and capability building. So this is what we focus on in our pillar 4, where we are doing targeted interventions that will support our projects. And finally, we have a cross-cutting pillar concerning our development as a trustworthy platform and partner within the global AMR landscape. The next slide, please. To deliver our projects, we have a top-down and bottom-up approach where we firstly encounter at the ministerial level as a top-down to secure the political commitment to eventually scale up the project results and align them with their national action plans. At the same time, we work bottom-up to ensure that the projects are locally owned, rooted in scientific research conducted by local research institutions, building on existing evidence and programs, and engaging with relevant local stakeholders. Of course, this year cannot be done by ICARS alone. We are therefore very keen on partnering with other organizations and programs, and we have already now engaged with partners as WHO, REACT Africa, the International Livestock Institution, GAMREF, the Fleming Fund, and moreover. It's also very important that it is not only biomedical interventions we're doing, we're also looking into the behavioral aspects on how to get these these interventions implemented, as well as making an economical evaluation, providing the cost effectiveness evidence for the government to take these interventions further. In the next slide, you can see here that we are right now engaging in 31 projects spanning 15 countries across Africa, Asia, Europe, and Latin America. And it's a bit difficult for you to see, but you can see the small symbols, which is indicating the different sectors where the project is addressing. And the next slide will give you a bit more on a specific project where we are looking at the environment in Tanzania. Here we are addressing the issue of poultry manure used as fertilizing in crop production, agriculture, and the food production. In Tanzania, as well as in many other countries, intensive poultry farming is on the rise to meet the increased demand for animal-derived protein, leading to a parallel increase in the use for antimicrobials for the prevention and control of the poultry diseases. This is creating a massive problem in Tanzania, as it is known that only 10 to 30% of the oral administrated antimicrobials are actually utilized in the chickens, leaving the majority to be excreted in manure as parent or metabolized compounds. The use further of this untreated poultry manure thus leads to environmental contamination with antimicrobial residues and antimicrobial resistant pathogens and genes across the food chain. This project here, which is initiated together with the Tanzania Ministry of Livestock and Fisheries, as well as the Sokoine University of Agriculture, they are theorizing the adoption of a simple and cost-effective poultry manure processing technology and processes will reduce the spread of antimicrobials in the environment, thereby intercepting the transmission cycle between animals, the environment, and humans. Next slide, please. In addition, and as part of the international JPI AMR One Health Call, ICARS funded LMIC partners in 3 projects, all covering environmental AMR interventions, bringing LMIC researchers to the large international JPI AMR consortia, thereby building capacity in these countries. Next slide. To deliver on our vision, as I said previously, we are working in close partnerships, and this slide here provides you with some of the examples across different pillars. I've already mentioned the IDRC Gender Project. We also have a Welcome Trust project where we are looking at the community engagement using the responsive dialogues, implementing patient views in the management of urinary tract infections. Next slide, please. So, as mentioned throughout the presentations, partnership is at the core of ICARS, partnering with low and middle income countries to generate the evidence needed for them really to take action on their national action plans and pull out AMR mitigation on the ground. Partnering with relevant stakeholders and organizations to strengthen our work, avoid duplication, and achieve synergy by working together. And not the least, partnering with other countries and foundations to join ICARS and take full ownership in the missions that we are having, embarking on this journey together with us. So thank you very much for your attention.
Thank you very much, Dr. Skov. Now I'd like to turn to the last part of this panel and invite Dr. Denis and Dr. Shepard to make your presentation.
Thank you very much, Mr. Chair. Can you hear me okay? So first, we'd like to thank the Council for the opportunity to be here today, and of course, thank you to Dr. Musmar for the invite, which what I think is the first in Canada-U.S. relations in terms of a opportunity to discuss the advisory group, our experience in Canada with yours. I do feel the need to correct something because this is being broadcast publicly, and in the off chance my mother was able to properly get the link to work. Hi, Mom. I'm not a doctor, but I thank you for that, but a humble public servant. The AMR Task Force in Canada was created in October of 2021. So a fairly recent task force. The work of AMR in Canada is not new, though, for almost 2 decades. A lot of work has been going on, but Dr. Shepard and I, being part of this task force, was a creation as a result of delivering on a mandate commitment that our Prime Minister delivered directly to our federal health minister to expedite and expand action to address AMR. On the next slide, please. So we're grateful to be here today again to share with you. We're going to talk to you a little bit about our federal strategy, as well as how it links up to our Pan-Canadian Action Plan approach. Share with you how our advisory group is working and how it's primarily been informing the development of that action plan, but also some other areas that we're looking at that may be of interest for you to take a look at. And we'll also pause a little bit on some of the environmental aspects that we're thinking about before identifying some possible areas of collaboration with your advisory group. On the next slide. So what we've been spending our time on since the creation of the task force is a lot of engagement, frankly, certainly a lot of engagement domestically, but also a lot internationally. There are a lot of countries that are a bit further ahead than Canada on a number of aspects. And here we'd like to thank the U.S. In general, not only this council, though we watch your work very carefully, but a number of international partners, and the U.S. is one of them, that clearly are leading in the space of AMR. And so we thank you for your contribution there. And I would like to thank also those, there are some of you as part of this council that have contributed to our thinking and our own federal strategy, and so we thank you for that. These probably aren't shocking to you. These are some areas that many countries are looking to take action on, but I will pause on some of the kind of Canadian-specific aspects. In terms of securing access, we have a twofold objective here. One is to gain access to existing antimicrobials that are already out there, but are not currently available in Canada, either due to regulatory issues, market issues. And so if you've seen that famous slide that gets circulated quite a bit in terms of pull incentives around the access to drugs of 18 or so that have been approved, and I think you have the majority of those. In Canada, we have but 3. And so already we're starting from a position of needing to gain access to antimicrobials that already exist. In addition to that, though, we do believe, and we are working towards pull incentives more broadly that would stimulate further innovation for new drugs. We also recognize, of course, that this needs to go hand in hand with preserving the effectiveness of the drugs that we do have. And so here we have a keen interest on stewardship and IPC as well as surveillance. But in a niche area also of focusing primarily on where we see the main gaps and the impacts on key populations. And here I'll highlight 2 long-term care facility patients as well as our Indigenous peoples clearly have needs in these areas greater than others. And in terms of both domestic and international roles, you can see here, and we'll talk in a second about the Pan-Canadian Action Plan. And from a global perspective, we're looking to complement efforts that are already being made by other countries, such as the U.S., of course, and to see where we can add value there. Next slide, please. In terms of our Pan-Canadian Action Plan, I should just say also, so we have a federal government action plan on AMR, but we realized that wasn't enough. The federal government does not have all of the levers to take the actions we believe are required on AMR in Canada, and so we're pursuing a Pan-Canadian Action Plan. So this is with all of our provinces and territories. It's a 5-year plan where ministers of all the jurisdictions in the health and agriculture sector would be making specific commitments. And while it is still a government plan with all the different levels of government, it also involves extensive consultation and inputs and collaboration with different partners in Canada, including Indigenous populations, but also industry and health professionals. What we've done is we've developed now 2 priority actions for each of these 5 pillars that you see on the left-hand side. They don't stand alone. They're essentially a package that work together. We whittled this down from what were some 55 proposed actions. It was maybe difficult, I don't know, maybe a bit difficult to get down to 10, but we thought that it was better to have 10 that we thought we could actually meaningfully progress on than 55 that would be quite difficult with the level of capacity that would be required to push behind that. And so we looked at the ones that we thought were most impactful if we were to advance them. Oh, I'm sorry. Is that better? Yes. I apologize. And so both from an impact point of view, but also from a feasibility point of view. So a practical, where the money is, where it could be leveraged, and where the different partnerships could be advanced to make these actions real. So with that, I'll pass it over to Dr. Shepard.
Thanks, Joelle. So do I have the right distance here on the microphone, or are we getting feedback? I'm good. Excellent. All right, so enter stage left our advisory group, which is on the next slide, if we could advance that. So you'll recognize some of this, I'm certain, from your own group. Our magic number is 13 instead of 15. We're a much smaller country, but we don't like to admit how much smaller, so we went with 13 instead of 15. The membership is designed based around the mandate, and the mandate in this case is AMR from a One Health perspective, also not new, but we decided to avoid the B, and we look at all microbes. So as a card-carrying mycologist, Dennis, you'll be very happy to know that fungi are indeed within the scope of, and so Candida auris is front and center for us. We've also let the protozoa and other types of pathogens come into play as is required. Viruses, a very important concept, and viral resistance is something that we're looking to expand into. So when you look at breaking our group down, you'll see that they map to those areas, but also to the strategic plan that Joelle just pointed out to you. So we have members that represent each of the 3 big pillars of the One Health stool: human health, animal health, and environmental health. We have 2 to 3 members representing each of those sectors. Then with a nod to our innovation plan, we have 3 members that represent antimicrobial industry innovation, starting at basic science discovery all the way through to venture capital and post-market authorization, including a member who's a president of one of the small companies that is developing antimicrobials in Canada. And then with Canada's longstanding interest in equity and deserving populations, in particular Indigenous health, as Joelle mentioned, we have 2 members that bring the social science dimensions, that bring equity considerations and Indigenous perspectives and ways of knowing on health to our discussions. So that's the makeup. We have a slightly different reporting system and governance than you do, although we're still assessing whether it's the best approach. They report directly to the task force. I actually chair the group. Joelle is the standing secretariat head, and that feeds in directly to the task force, and then we are the liaison with the other government departments. And we're really interested in seeing how it works in your model, where you actually have the government departments sitting around the table with the members, because we're open to looking at whether that's a more effective governance structure. So what have they been doing since we started up? And as we just mentioned, this is a young group. This is a young task force. This is a young organization. You can imagine they focused much of their attention around the Pan-Canadian Action Plan. So if we go to the next slide, we have a summary there for you of a bit of what they've told us about our action plan. We've had a very iterative process with them, and they've given us a lot of feedback on the sort of structural and the form aspects of how we've set up our action plan, how we got from 55 down to 10, what an action plan looks like, what's the difference between an action plan and implementation plan, and how we find that magic resolution between something that everybody can agree on, but something that actually has hard commitments and that is resourced appropriately. And that's where we get into some of the finer details. So they've given us a lot of advice that I'm not going to go into for the interest of time there, but I will highlight some of the content areas where they gave us some specific feedback. And in line with today, one of the big ones that we heard right out of the box when we first presented the issues was, we want to see environment writ large. We want to see it in each of the actions. We want to know how you're going to convert the classic human-animal health version of One Health to a true, robust three-sector strategy. So that was a major area. And then the other one was they really wanted us to lean heavily on the innovation pipeline and both the pull and the push side to really do our part in Canada in not just securing access, as Joelle mentioned, to these existing antimicrobials, but trying to do something to restore the broken market that we heard about early on in our conversations this morning. So if we go to the next slide, I'm going to just give you 2 or 3 of the actions and some of the work that they're going to be doing that's either relevant to the innovation or relevant to the environment, because I think those are of interest to this group, both with what's going on with Pasteur and, of course, the topic of today being environment. And then we're going to shift a little bit and we're going to dig into what Canada is trying to do in the environmental AMR sector before we wrap up. So, first pillar in this plan is, of course, research and innovation, and we have the 2 actions here. One is hardcore innovation. How do we develop new antimicrobials and alternatives to antimicrobials? And the second is, outside of the innovation pathway, how do we develop a broad-based, multi-sectoral, collaborative One Health research vision for Canada, both intra and extramurally, to tackle AMR? How do we have our special sauce that will be complementary to what's going on the global agenda? And I just want to highlight the top action there as to where the advisory group is helping us, because that's their ongoing work right now. And when we look at what's going on with a lot of these pull incentives, economic incentives, things like the UK and Sweden are doing, where we see the lens now is looking at existing drugs that are out there and how do you prioritize what you want to buy for value. We'd like to take that vision and flip it a little bit and look further and develop something that's a little more evergreen and a little more forward-looking and say, how do we develop a framework that says, what do we need from a bug-drug combination point of view? What are the AMR unmet needs in our country now and going forward, and how do we have a framework to prioritize them? So that when whatever structure is put into place, we can actually prioritize by risk what we're going to call for, what we're going to lean in on with, whether it's tenders or supports or push or pull. And so we're bridging off the surveillance risk assessment frameworks that public health groups have done previously, where you prioritize risk based on things like morbidity, mortality, national burden, communicability, global commitments, equity considerations, and actually asking them to develop a true point score system that would allow us to compare the apples and oranges of, say, multi-drug resistant gonorrhea with ESBLs or carbapenemase producing gram negatives. And obviously very different considerations here, but there may be a rationale for why we would choose one over the other. Next slide, please. Then moving into surveillance, this is where they've told us that we need to start thinking heavily about environment. And I highlight this because it harkens back to what we just heard about, which is the kind of the concept of how much is enough. And when you have limited resources, as even high income countries do, how do you balance your investment versus your return? Surveillance is a great example. You can't measure everything all the time, everywhere, despite what the movie would suggest. You have to pick what it is you're going to measure that's going to have impact, that you can actually action and that will lead to impact. So we all know that we want to measure multi-drug resistance in our hospital ICUs because that's going to allow us to do something. But when we wind that back to the animal sector and now the environmental sector, how do we prioritize where we put the dollars we have to make a true integrated surveillance system that's actually going to return value for investment? Is it a sentinel system? Do we need to have passive, active surveillance? Which transmission matrices and which sectors? These are the questions we're asking our advisory group to weigh in on, and perhaps this is something we can look at going forward that would be an area of shared interest in developing some sort of a framework that can actually measure value for surveillance dollars spent. If we skip to the next slide, which is my big jump, and I think you should take me straight to leadership here on your slide 60. Thank you so much. This is just a nod to the fact that we really do want to work in complementary fashion with what's going on internationally in the US and elsewhere. We are a small country with big aspirations, but we have our specific niche areas of interest. And we're asking the advisory group, and we'd be interested to hear from you, where we contribute as Canadians on the sort of global stage. We don't want to boil the ocean here. We know we can't. We have our own thoughts that we think we're a research-intensive country, and so evidence generation is something we can contribute to. Equity is born in our DNA. It is something Canada is known for, and it's something that we want to step up further on a global stage to look at global equity considerations. And then, as I've mentioned, of course, One Health is something that we all share. We've had an integrated surveillance program with human and animal health for many, many years. We'd like to see if we can make that an integrated human, animal, environmental health surveillance system that is, as I mentioned, efficient and returns value for money. So that brings me to the environment on the next slide. So what are we doing in the environment? And we heard a beautiful summary of the UNEP plan, which is really a very comprehensive document that outlines all of the potential ways that environmental matrices can be affected by anthropomorphic activities and by microbial migration. It's honestly a beautiful piece of work as a scientist reading through it. But now we have to operationalize that in a country that has the resources that a country has, and that has its unique context. Canada is not the same as Thailand. It is certainly not the same as India. We have different manufacturing, population centers, environmental considerations, small population, big country, lots of snow. How do these make a difference when we're thinking about environmental AMR? So if you switch to the next slide, here's the way we're approaching this. We're starting with what is already on the table. Things like the UNEP plan that identify the key sectors that we think we need to consider, and then mapping those to the Canadian context. And I'll get to some specific examples so you can see what I mean. Once we've mapped those to identify which are relevant and non-relevant in this evidence map that we're currently creating, the goal is to actually identify where our knowledge gaps are as to how important those individual areas, sectors, and transmission matrices are, fill whatever gaps, and move that into surveillance and monitoring to confirm, followed by targeted action. It's easy to say, well, we already know and we should put in the standards and everything else, but I think there's a lot of arguments to be made for the fact that country-specific considerations may change the ranking of how important some of these sectors are and where that value for action is going to be. And acting blindly and using resources when we don't know what the return on investment is a bit challenging in our current post-COVID context. I'd like to know if we do something that we're going to actually see something that we can measure with at least a reasonable probability of success. So if we go to the next slide, here's some examples. Pharmaceutical and chemical manufacturing. At first glance in Canada, you go, that's irrelevant, right? We don't make any of the APIs. We don't have antibiotic manufacturing plants. But it turns out what we have is a lot of fill and finish. And those fill and finish plants actually, it turns out, are dumping antimicrobial residues as part of their process. So for us, a major focus will be looking at fill and finish plants, actually measuring some of their antimicrobial contamination downstream and seeing if targeted regulatory action or standards in that specific space would be a much more useful one than going across the industry. In crop production, we actually have two competing priorities that are really kind of interesting and I think illustrate the national lenses. So we have a lot of aquaculture where there's a lot of antimicrobials being used, and there has been reports of resistance related to them. So our Department of Fisheries and Oceans is actually moving already past the evidence stage directly into surveillance and monitoring, looking at antimicrobial residuals and AMR burden in aquaculture with a view towards setting standards, action down the road. So that's a very advanced one and very much in line with the potential of environmental matrices. But contrast that with the crop story. Canada is a bit of an outlier in the crop story. Many of you are familiar with the azole antifungal issue and Aspergillus fumigatus resistant, the famous TRL98H mutations that have been appearing in the environment related to azole use in Europe and have been transmitted to humans to result in human resistance. I know I'm speaking fungal, but the principles apply. Canada uses large amounts of azoles in our crops. We do not have TRL98H mutants. I personally look for them. Many other people have looked for them. There are none in humans in Canada. Why is that? That seems like we have something to learn. Because for whatever we're doing right by accident, perhaps that's something that is transportable. So even where we think we know about clear evidence of a link between human activities, environmental contamination, and resistance, the exceptions may actually prove to inform our actions and potential policy options. And then lastly, there's of course the healthcare systems that were identified before. We have lots of hospitals, very concentrated healthcare systems in Canada. So a real opportunity to study the waste and contamination issues that are coming out. And so across that, we have the initiatives that are already ongoing that aren't on the slide, that are looking to address some of those knowledge gaps. And I'll highlight 2 or 3 of those before we wrap up. The first is intramurally, we have something called the Genomics Research Development Initiative, GRDI, which is actually a genomics-based large-scale multi-departmental program specifically designed to address identifying the important transmission matrices in the One Health spectrum for AMR. So bug-focused and specifically asking the question in the famous confusogram of how AMR migrates through the One Health spectrum, which of those thin lines is needed to be bolded in the Canadian context and highlighted for risk assessment, surveillance, and action? Extramurally, we have a twinned system. It's from Genome Canada, one of our large-scale research organizations, looking to develop genomic technologies for AMR monitoring in water. And this is not simply wastewater, which we have government programs already looking at, just as CDC does, but this is looking at other water systems, things like runoff from farms, natural water systems, and water treatment plants, because one of the actions that was highlighted before was, how do you treat water so that it comes out AMR or AMU, if you will, antimicrobial residue, perhaps better, free or below whatever standards you set. And then I'd mentioned it before, but I'll just highlight, we have wastewater strategies going on inside the government that we're working on. In addition to the classic genomic-based monitoring of AMR and wastewater, we have a program that's about to launch measuring antimicrobial residuals in similar impaired wastewater samples, actually, from population centers that we can use as a surrogate for antimicrobial contamination from urban centers to quantify how much of a risk we think this is in the Canadian setting. So that should give you just a little bit of a flavor of some of the things that we're doing and the perspective we're taking on it as to how a national view could perhaps inform both our actions and hopefully some international perspectives. So I'll give it back to Joelle for the close here.
Thanks. We just want to wrap up and didn't want to leave the conversation without floating some potential areas of ongoing discussion that we could consider. So on the next slide, I'll touch on these very briefly. Dr. Fukuda, you mentioned, the obvious place to start on the environment being research. So surprise, surprise, this is where we start as well. And so looking at research, whether it's the difference between emergence and transmission and how that works is an area that we posit might be of interest. The second is around just broader research strategy. And so there's a few areas here that we would highlight. As Dr. Shepard mentioned, this is an area that we're working on within the advisory group, and so informing how and where the research needs to get done. For example, ones that we may think are unique and wonder if you do as well, which is around the fact that AMR is not solely just a medical issue. From the behavioral perspective, we see a lot of value in looking at how this might influence stewardship and behavioral practice, both on the human and the animal side. And then, given our shared interest on pull incentives, wonder if there's something here as well. We watch and admire the progress that you're making and keep all things crossed for PESTER round 2, I suppose. And so wish you well there. In Canada, we've got initiatives that are moving through the system as well. When they come to fruition, we will need to figure out what we all do next. How do we go about implementing? So we've started to shift some thinking there as well. Dr. Shepard mentioned the unmet kind of how do we prioritize is step one. There's a few other areas that we're looking at though as well around valuation. Yes, other countries have valuation models, but what do we think about that? We're going to have to decide that. The distribution and procurement model, really operational things that will have to happen should ever some of these big policy and funding decisions come to fruition. And just as Europe is doing in terms of regional policy planning, things like the HERA report that came out last week, or the transferability initiatives as well. Is there a way of looking at, given the shared market that we have, options as to how we would implement these incentives? So with that, we thank you again for the opportunity to be here today.
Thank you very much for your presentation. I'd like to thank all the panelists for your comments. We now turn to the comment period. For those members of the panel who want to make comments, please put your sign up. I'm going to start. I'm going to take the chair's prerogative and start while other people get their thoughts together. You all have covered many topics, and in particular, I want to ask you about the position of AMR originating in the environment. We've had decades of experience now in dealing with AMR in the human setting and in the animal setting, and I'm hopeful that we have learned some lessons. The question is, how can we apply those lessons to the issue of AMR in the environment? What are maybe key steps in jump-starting the program? And I would address this to each of the panelists to get started. So maybe, Dr. Pruden, can we start with you, and we'll just work our way across.
Certainly, that's an excellent starting point. So how do we use antimicrobials, antibiotics, right? So they're either sprayed on crops or they're consumed by people and animals, right? So that means that they affect the gut and skin microbiota and they go into the environment, right? So one route of that is those resistant organisms themselves being enriched and circling back through exposures, through water, soil, air, right? But the other is the actual, I think you alluded to this, soil, for example, the environment, it's been referred to as a reservoir of resistance genes. Of course, many of our antibiotics are discovered in natural organisms that produce them, right? So these resistance genes are out there, and we don't even know most of them. We know the ones that are in databases and that show up in patients in the clinics, and we've been cataloging them. So I guess that's kind of a long-winded answer that, we have that framework of how it spreads, and, the literature is voluminous of specific examples of where you see it crosses over. And so I think it's a combination of seeing this big picture and understanding where are those critical control points of evolution and transmission to humans and animals. And then coordinating that action so that it's relevant local, that it is synergistic with everything else we have on our plates, like climate change. So I think it's a combination of moving the action forward where it makes sense and where we're able to, and then moving the research forward so we can better laser point where to focus as we go along.
Right. Dr. Nadelia?
Thank you. Nothing to add to Amy's response. Thank you. And it is not Dr. Ndoye, it's just Fatou Ndoye. Thank you.
Thank you. Dr. Fukuda.
Dr. Blazer, I think that in terms of what to do, the issues are reasonably clear. I think that from a lot of studies, we know that the environment, as Amy was pointing out, it's both a reservoir, and it's highly likely that most of the ARGs that we're going to be dealing with are already existing in nature. It's also very clear that antibiotics act as an accelerating selection force. And so in terms of what to do, it's one of the clearest examples of where interventions can be argued for, which is that the actions to reduce the contamination of the environment by antibiotics has potential major benefits. We can't say how much do these antibiotics increase the chances that it will create the next new resistance pattern, but we can say that it definitely pushes things in that direction, and that it is a very clear point of intervention. And so in terms of that issue of do we have enough evidence, I think we can make a strong case that the evidence is already clear enough. We're going to get more precise details, more research, but the bulk of the evidence which is needed is already there.
Thank you, Dr. Scove.
Thanks a lot. I'll continue a bit what Kiki ended, that I think there is definitely a need to understand more the relatively risk from the different sources. Having said that, I think we have plenty of information to start already with the interventions. I don't think we need any more evidence that it is needed to do so. So interventions and research is needed hand in hand.
Mr. Denis, the honorary Dr. Denis.
Yeah, I was going to echo a similar point. What I think your question is, what have we learned from some of the other sectors? I think we've learned that to communicate the risk to decision makers to be able to take action requires an ability to articulate the risk and really understand what it means. I don't know how many reports I've read around they're finding resistance genes, for example, in some body of water, but then it kind of stops there, right? Like the so what factor is a little bit missing. I read one report that you'd have to drink like 200 liters of that water to have some kind of human impact of some kind. And that's not to say that the impact on the environment itself isn't important. It is, but the flip side is in some cases I would have to imagine that the emerging kind of resistance might actually be helpful to the ecosystem from the environmental perspective there. But that may be at odds with the human or animal threat that it may pose, but we don't really know. And so again, having the evidence to be able to properly articulate the threat, and it's not just the threat in and of itself, though that's important, but realizing this is this is part of a broader conversation on AMR in general when we look at the threat and risk of many other things that we can be doing to address the problem. So I think all the more important for that, for us not to be, for us actually to be looking for the evidence of what is the threat risk analysis that we're dealing with to inform the action. Thank you.
And last, Dr. Shepard. Yeah, so in my head, I divide this between emergence and amplification and transmission, right? So the whole emergence concept for me, I think we're not there. I don't think we're even close to there. We know that almost every gene that we've ever looked for, that every antimicrobial resistance gene we've ever looked for, we can trace back to an environmental origin. We know that when Jerry Wright cracks open 10,000-year-old caves, he finds Van genes that have been there before anybody invented or dosed the first dose of vancomycin. So it's all there, but measuring it, finding even enrichment in a certain matrix, water, soil, whatever, in the context of an exposure, leaves out the whole transmissibility issue, right? There's a major species barrier concept. You can have as many of these environmentally resistant organisms as you like if they can't colonize the human or transfer their genes to an organism that can colonize the human or animal or wildlife species you're interested in. And I don't believe we're at a place where we can quantify that second piece of dark matter enough that we know what to do with an increase in novel ARGs in the environment. So I think we leave that for now as pure research until someone figures out a better algorithm to do risk assessment on an increased pool of a novel antimicrobial resistance gene in water. How we figure out the risk that is to the target species, human or other. Where I think we can do something that's useful is when we actually start with things like very specific scenarios. Let's pick urban wastewater, for example. We look at very specific questions. What is the most abundant antimicrobial active compound in that wastewater? And is there a linkage to antimicrobial resistant organisms? Because then we get into the transmission amplification cycle issues. There's beautiful work on this. There's a study from University of Toronto a while back that looked at wastewater in Toronto. The only thing they found that was, or at least it was 90% of the antimicrobial activity was triclosan. not an antibiotic per se, but what we would think of as a disinfectant. And that's relevant because the target of that particular compound is very similar to some of the new MRSA drugs. So, you know, there you can see where maybe that's something that we can then think about from an intervention point of view. We're about to launch 3 new drugs that have the exact same target as something that we are seeing is actually driving in vivo selection of resistance in urban settings. That's a little more evidence informed. And hopefully it will get us around some of the stumbling blocks we've had with the animal sector. It's very easy in Canada to say that 82% of antibiotics are used in the animal sector, and therefore we should reduce antimicrobial use in the animal sector. It's much harder to say, well, it's actually the tetracyclines that are being used, and tetracycline resistance is a massive clinical human problem, and that's why we need to reduce tetracycline use in the animal sector. And so those conversations become a little sticky when you actually don't have a really nice dotted line evidence map and you just started looking at bulk statistics and numbers. I think we need that level of evidence if we're going to be introducing interventions that do have knock-on effects, economic, social, and everything else.
Great. I'd like to thank the panelists for answering that question. Now we turn to Dr. Lakshmanarayan with his question.
Thank you, Marty. Thank you all. Excellent presentations and you know, all very complimentary. So that was really helpful. So first question is actually for Dr. Pruden, but also for Dr. Fukuda. You know, you started by saying that the environment has always sort of been missed out in this whole, you know, tripartite, whatever, the human, animal, and environmental sectors. You know, it is a pity, but I think it's because we don't really have any sense of a cost of AMR in the environment. So in other words, if bacteria become resistant in the environment, it doesn't really harm anyone unless it hits a human or an animal, right? Which is why the environment is still a conduit. It is not necessarily an affected party per se. So even if all bugs in the environment were resistant, would that really be consequential unless it actually, you know, went to a human or an animal? And that is actually a question. So the second part of that is then it comes down to this question of hazard versus risk. Just like there are probably, you know, millions of viruses floating around in bats, and we're not trying to sort of, you know, kill all the bats just to get rid of viruses. It's our exposure that's the problem. It's not the presence in the environment. And there's a lot of, you know, scary stuff out there in the environment. And so should our focus be on trying to quantify or trying to, you know, prevent resistance, you know, in the environment? And here, you know, I turn to KG's point as well to say, you know, we absolutely should unambiguously try to stop resistance in the environment. It might be hard to do. Or should we focus on identifying the risks? There's a lot of hazard, but the risk may come from a small set of pathogens, and understanding how that risk gets to either us to animals would that be a better use of resources rather than trying to do, say, what Sweden does, which is, you know, treat their sewage to, you know, to remove antibiotic residues and prevent resistant pathogens going into the environment. I don't think we can afford to do that in the US, let alone, you know, do it in most LMICs where sewage treatment itself is a luxury. Forget about treating sewage for AMR or antibiotic residues. So, I just want to sort of, you know, have us pause and think about the context in which we're thinking about these sorts of things. And because otherwise it's not really going to be taken seriously, and we'll risk what happened in 2001. You know, we give countries a list of, you know, 500 impossible things, and then they look at it and say, you have no understanding of what our contexts are. We're trying to just treat sewage, not, you know, forget about doing this. And perhaps think a little bit more about where the risks to us come from. Do we understand where the transmission risks are from the environment to us well enough right now? And since all of you suggested research, is that something that we're spending enough money on and enough attention on? So embedded in that question is really, you know, a cost effectiveness question, which is what's the best use of our money here when we deal with the environment? The other point I was going to make was, you know, KG, for your, you know, I love the way in which you effectively talked about, you know, horizontalizing AMR. I think one thing we did in 2016 with the UN, the UNGA meeting, in which you played a major role, was I think in trying to verticalize AMR, we've not really tied it to enough other constituencies, whether it's child survival, whether it is, whether it's aging, whether it is, people interested in surgical outcomes. And there are enough of these vertical other pillars that we need to tie it to, and we've really not done a very good job of doing that. So thanks for, reminding us of the need to do that. But I think another part which I might add to it, which came out actually a conversation just last week, which I had with with a senior government official in New Delhi on AMR. They're like, we're not really interested in stewardship. And I was like, seriously, you're not interested in stewardship? They said no, because anything where we have to say no to someone getting an antibiotic is something that we find difficult to really do. If you have solutions like new drugs to help us deal with resistant pathogens, we're interested in that, but not really with a solution which is of denial of access, which is what stewardship is. So that's another question for you, KG.
So let's thank you. So Dr. Pruden and then Dr. Fukuda.
Those are a lot of questions. Well, I can start by saying that, in the UNEP report, we were very mindful in speaking to the role of the environment. And so we landed on referring to environmental dimensions. And they speak to exactly what you described. So, what contributes to evolution within the environment, and, maybe that's more or less of a concern, but also the environment as a dissemination pathway. So, regarding where exactly we should focus our attention first, I mean, the report's a starting place, and there is a long menu of options. But as everyone here has emphasized, it's context specific. And so I think, the next steps are, how can we help various nation states implement the recommendations, and what is most appropriate for their setting? And I think it's been mentioned, like, okay, well, if I now deal with environmental AMR, what am I not addressing, right? Am I not going to provide antibiotics to people that need them? Am I not going to treat my waste? So I think it's going to take some support in conversations like these and within each country. So WASH is a great example. I think we all agree that every person on Earth needs a place where they can go to the bathroom and ensure that the water is clean and that disease is not spreading, right? Well, it just so happens that's a great way to help prevent the spread of antibiotic resistance and also the need for antibiotics. Risk, and hazard. And those terms tend to be used interchangeably, and they're not the same thing. You're right. We can't blast away every antibiotic resistance gene on Earth. So I think part of it is this surveillance is getting a lot of attention, that, how can we implement some robust environmental dimension of surveillance so we can get a sense of what is working. So what is reducing the hazards as we know them, but also, specifically getting an idea of where transmission is happening and where we can focus on that as well.
So Amy, we're just going to move ahead because we have a lot of questions in the queue.
I think KG wanted to add to that.
Sure, maybe just to add on to what Amy said, and Ramanan, thanks for these very complicated questions and issues. I wouldn't have expected less. I mean, the art of governance, I think, is oftentimes adopting the right perspective for the right issue. So if we look at something like AMR, I think we have the issue of, do we apply a precautionary approach in some instances, or do we say, in fact, this is a cost or return on investment type of issue? And when do we apply that perspective on these things? And you raise the issue that we have millions of viruses, but we can't treat all of them the same. And right now it's been estimated we know about 5% of the viruses which are already out there We don't treat the coronavirus or SARS or H5 the same as we do other viruses. But in applying both of these things, we do have measures with viruses such as biosafety, biosecurity issues, which are not directed at any specific issue, but they are issues to reduce risk. And in a sense, they are a kind of application of a precautionary principle. If we apply these things, no matter what situation we're dealing with, we are in a better position. And so when I come back to something like the antibiotics going into the environment, regardless of the amount of detail that we know on emergence or transmission or these sorts of things, I think in balance we are dealing with a precautionary issue, which then dovetails into, or an issue in which that principle is important. And part of the reason for that is, again, you raise the issue of we are not dealing with things or combining things horizontally very well. If we look at Sweden's approach in terms of wastewater treatment, it can't be applied by many countries for AMR. But if we begin to look at, are we going to do wastewater treatment at a more technologically advanced level, the whole issue of environmental contamination, phthalates, forever chemicals, these things begin to come on board. And I think that combining both that approach of joining issues together makes it less necessary, I think, to address each specific issue as whether this is risk reduction or whether this is addressing a hazard, or whether it's a cost issue or whether it's a precautionary issue. But it is the difficulty of governance. You know, you have to make those choices. But when I look at those things, I do think that there are actions that we can take which are prudent. I think the climate is the outstanding example that we're dealing with of while we waited for more evidence, and we still have people saying that climate change is not occurring, we are in a terrible situation right now. And I think there are other actions which it's not possible to argue we should take in right now because we need more evidence. But I do think that we have to tease through those issues one by one and then take the appropriate approach for each of those questions.
KG, thank you so much. We have 7 questions and we have about 15 or 20 minutes. So I would ask each of our questioners to ask just one question. Questioners keep the questions short. Respondents keep the answers short. Dr. Paul Plummer.
Yes, so appreciate the presentations. Several of you spoke on the surveillance, the need for more One Health surveillance and integrating environment into that. And I agree. The challenge that at least my group sometimes faces is that largely on the human and animal side, we're still quite culture dependent, or at least that's what we're most frequently doing, is culture in the places that we're surveilling. And on the environmental side, we tend to be quite genomics based. And so my question is, as y'all have thought about that, how do you see us balancing that? Do we need to be investing genomics across the board? Do we need to be investing culture across the board? Or do we invest more time in trying to figure out linking our genomics to our culture data in complex communities? Anybody that wants to comment?
Just take one comment.
Yeah, as a card-carrying microbiologist, I can throw in at least a thought on this one. So I think the answer is it's just time, and that there will be convergence. I don't think that I would invest a lot of energy in trying to develop anything culture-based for the environment. It's simply not a practical, useful solution. And you know, we know what's happening in the modern microbiology lab. It's drifting further and further away from culture and more into genomics, especially on the surveillance side. You know, we're moving at our national gonorrhea surveillance system. We're moving to try and get rid of antimicrobial susceptibility testing, just completely. And we're going to move to a fully based PCR sequencing, algorithmic genotypic surveillance, and that'll be it. and therefore, not a good example for the environment, because one hopes there's not a lot of Neisseria gonorrhea floating around in the environment that we need to surveil, but you get the idea.
Thank you very much, Dr. Julie Shimzak.
Oh, my question was already answered.
Question answered. Dr. Dennis Dixon.
I'll save our time and pass.
Very well. Dr. Michael Craig. Mr. Michael Craig.
Thanks, and I'll just keep it brief for a comment here, but I will note that CDC has worked with all of you, I think, in some capacity, and I thank you for your leadership and support on this. The environment is a complex area, and I'll just note we're going to have a couple CDC speakers, Drs. Chow and Walters, talk later about two areas where the environment is playing a role, and I think touching on One Health in new ways that I think are quite concerning. I think the other thing that I would sort of magnify from some of the comments, especially from our partners in Canada, is how do we focus on the intervention? Because we cannot decolonize the world, right? And so how do we focus on the areas and those points where there is a reservoir with risk to whatever we're looking at, humans, animals, et cetera, and how do we focus on the intervention there to be able to do it? Because when we look at the scope of this problem and we look at the soil issues, the water issues, the challenges of different types of environment, we really need to focus and prioritize on those areas that have the highest risk and have, the best proverbial bang for the buck to address some of these things. Thank you.
So I don't know that there's a silver bullet, but I think an example is the metagenomic sequencing of sewage that has really taken off. And you see striking patterns, right, that, happen to be higher concentrations of antibiotic resistance genes in countries where there's more lax policy for AMR and lower levels where there's more stringent policy. Now that's a very, very broad brush, but I think as we dig deeper and start to actually look at those genetic signatures in this example in sewage, you can get an idea of trends and within the community and across communities and where exactly there are issues going on. And so with the pandemic too, there's a lot of infrastructure built on the sewage surveillance. So that's just one example.
Great, thank you. Dr. Jason Newland.
Thanks, everyone, for the presentations. This is specifically to the Canadian colleagues. I appreciate you guys being here with your efforts. Obviously, preventing infections will lead us not to use antimicrobials, or preventing the need for antimicrobials in any of these areas matter. But specifically to you all, is there places in your report or in your action plans around innovation for vaccines, innovation to behavioral uptake of vaccines, and how do we do more to think about that prevention at a higher level, even at a level of maybe at the global standpoint of malnourishment, poverty, and such, that will have a big impact on infections and the need for these life-saving antimicrobials so we can use them when we need them?
Yes. So there's multiple places where we specifically call out vaccines and the importance of vaccines in controlling AMR as preventive measures. We actually at one point tried to generate the confusogram of how a vaccine is capable of reducing AMR, and the number of loops that you get between AMU, number of infections, therefore less AMU, therefore less inappropriate AMU, it becomes quite impressive. So we have it in our innovation, under innovation, it's antimicrobials and alternatives, and we bundle vaccines under alternatives. Prevention is an alternative to treatment. That's our lens, and it's much faster to write that way. And then in infection prevention and control, we specifically call out the idea of improving adult vaccination campaigns for things like pneumococcus, influenza, any of the classic viral vaccines that we know reduce inappropriate AMU or appropriate for microbial bacterial complication AMU. So absolutely on board with you there.
Thank you. Dr. Jay Garland.
This is a specific question for you, Dr. Pruden. I mean, the UNEP report, you emphasize the three sectors, and healthcare and healthcare waste is important, but I'd like to hear your thoughts about the broader sector of wastewater processing and even maybe drinking water. as an important role here, and viewing that as an important sector for consideration for protection of the environment.
Right. So we framed it on the specific value chains of healthcare delivery, food production systems, and pharmaceutical development, because within there in a policy framework, there are very specific actions that can be taken. But that is then embedded in the environment, basically the inputs and the outputs. And so, yes, the environment is there in all of those, and water specifically. So all of those sectors are producing wastewater, right? And then that's intermingling with domestic wastewater. And then, of course, big reason why we care about wastewater is drinking water. So it's there kind of in the surrounding, it's embedded in that.
Great. Dr. Elaine Larson.
Sure, thank you. This is for anybody. I'm concerned about
Your microphone's not on.
Sorry, closer? Okay. Yeah. I'm concerned about the comment that clinicians are reluctant to deny patients an antibiotic. First of all, the risk communication, the language. Sorry? Oh, okay. I can hear myself really well. No. Anyway, okay. Just to readdress, I'm concerned about the comment that clinicians in various cultures, I would say in most cultures, are reluctant to deny a patient an antibiotic if they expect one or want one. But there's pretty good research that to show that patients want a prescription for something and they want a recommendation, but they are very amenable to a suggestion from a clinician for alternatives. So my question is, are we preparing our clinicians to educate patients in appropriate ways so that they aren't expecting inappropriately antibiotics? In many cultures now, people don't expect an antibiotic when they get the flu or when they get COVID. So it's a matter of education. And my sense is that the clinicians don't know how to talk to the patients about it, or they're busy and it's faster to simply order something. And that to me is very, very dangerous. So there are expectations, for example, in the Joint Commission guidelines for AMS that you educate patients. But if clinicians don't want to do it, what's going on culturally to make sure they know how to communicate with patients appropriately?
I might direct that to Dr. Skov and maybe Dr. Shepard.
Thanks a lot. I think this is a common known problem. I don't know how to solve it easily, at least, but it is really an issue. I think the wait and see receipt that you can give is one of the solutions that has been tried to do. So you're bridging the expectation to get something and the clinicians has something to offer, but at the same time you are saving. But this here is an issue we are facing all over, not only in high income, but especially in low income countries as well.
Dr. Shepard, do you have anything you want to add?
Yeah, just some things from the Canadian context. So there's an organization called Choosing Wisely in Canada that's been very active in this space and has developed actually a viral prescription, so a cold prescription. It's actually a formal piece of paper, boxes ticked, you hand it to the patient. It's been shown to be highly successful. It's one of the interventions we're trying to support and roll out on a larger scale. The other thing I want to comment on...
CDC has the same thing.
Yeah, same concept. The other thing I want to mention is that it's not just about patients demanding. There's also quite a bit of evidence of defensive medicine in the prescription of antibiotics. And I think the number is 88% of physicians admit to having used antibiotics as defensive medicine strategies. And I'll confess, I'm sure I'm one of them that, not sure, I don't think, but you know what? I don't really feel comfortable taking the risk kind of a response. And I think that's an area where if we're looking at numbers as high as almost 90% of physicians doing it, we've done very little to address that. And we've done very little to give physicians confidence, even in Canada, which is a much less medical legal culture of how do you feel confident following a guideline that you know is a 95% certainty of being right, and how comfortable are you with the 5% of being wrong?
Thank you. Dr. Stephanie Black.
Hi, thanks to all the speakers for great talks. I am coming from the perspective of a local health department, so the Chicago Department of Public Health, and my question is directed to Dr. Fukuda. I was happy to hear you say that, all response is local, and we are very excited to be, thanks to funding from CDC, have staffing to launch a One Health initiative at Chicago Department of Public Health. And I'm very interested in, a cost-effective response to environmental intervention, and also something preferably that's evidence-based. And I heard mentioned the idea of looking at the disposal of pharmaceuticals, or also potentially treating hospital effluent. And of course, we have many academic centers. And I'm just, my question is, are we there with the evidence base, or I thought I would ask the experts, what might be a low-hanging fruit intervention that we could look at, kind of piggybacking off of Michael Craig's comment. Thank you.
That's a really good question, and I'm not sure I can answer it directly for Chicago, but I can tell you, for example, in Hong Kong, where I was for 5 years, and which is probably similar in size to Chicago in many ways, the government approached this by having both a technical group of people advise on issues, as well as a sort of high-level management group look at the issues and advise the government on what ought to be done. And I think it's a sensible approach, and I think it works pretty well. And they based their agendas by looking at the Hong Kong Global Action Plan, which is based on the Global Action Plan, and so had a fairly rigorous way of going through all of the issues. And I will say on those meetings, a lot of the issues focused on the healthcare system and to a certain extent the agriculture system. I think the environment was not really on their radar screen. And so we raised it as an issue that had to come on. And so I think a lot of those questions, what effectively can we do, were being explored. And so, for example, sewage surveillance was started up and those kinds of things to begin to monitor, some studies looking at rivers and so on. So I do think that it's hard to answer what's the evidence for cost effectiveness. I do think it's possible to point out that there are other locations like yours which are trying to grapple with the same thing. And it may be more of a process question right now about how to get to answers which are acceptable to Chicago.
Thank you. Dr. Dennis Dixon.
I'll just respond to something Dr. Shepard pointed out, and that is the instinct to want to do good. And it's exceedingly difficult to generate evidence in clinical trials in today's environment that actually proves the level of evidence suggests you do not need to use antibiotics in certain patients in the ICU, for example, to satisfy everybody's concerns about doing harm to subjects, to satisfy statistical considerations, and to do that in a way where you can actually enroll the resulting trial. So I hear it's getting whiter by the minute as we continue to solve this problem.
I'll just ask the final question, and maybe I'll address it to Dr. Skov. Much of the problem of, a lot of the problem of AMR in the environment is in low and middle income countries. But AMR is a worldwide problem. And so the question is, how should the cost be shared for this? Because, well, let me just stop there. Thank you.
Thank you very much for giving that one to me. I think one of the really important things here is that we are one planet. And actually what is happening all over is actually affecting all of us. And this is really, that was mentioned before, this about, what is the risk and size. So basically it takes one or just a few successful jumps. If the right conditions are there, well, we can just take COVID. It's really a few jumps that are needed cross-sectoral to do this. And this means that the responsibility to do these things, I think, lies on all of us. And one of the biggest issues that we are facing is that the most of the assistance is probably not generated in our part of the countries, but is really generated in low and middle income country settings, but they are spreading inevitably to us. So I think that there is a need for a global solution for this, but how you're going to share that piece of cake, I think I'll defer that to others to answer.
Very briefly.
Very briefly, I think this is really critical because I think if we approach it as a cost issue, it's not answerable. But I think that you have to look at what's the perspective from low and middle income countries, which in a lot of instances is we don't have access to these antibiotics, and you're asking us to address something else, which is irrelevant to us. And so I think that you have to have a more holistic approach in terms of low middle income country concerns versus economic and how do we pay for all of these things, and that they're all part and parcel. But I do think we have to begin with what is of importance to those countries which are affected. And right now it's not AMR in many instances. It's really, we simply can't get a hold of the health things that we need.
Well, on behalf of PACCARB, I'd like to thank our panelists for a very inspiring and educational panel. And now we're going to adjourn for lunch. And Dr. Musmar, do you have a comment?
Yes, thank you all for joining us. I ask people in virtual land to please join us back at 12:45. And for our council members and presenters that are staying for the afternoon, please join us next door for a paid lunch. And thank you. We'll see you in a bit.
Produced by the U.S. Department of Health and Human Services.